Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I'm Richard Richard on the MakeCode forum.
And I'm Joey at J1 on the MakeCode forum.
And today we are continuing to work on the extension we started like a couple streams ago. So if you want to see us write a bunch of low-level JavaScript physics engine stuff, you've tuned into the right stream, because that's what we're doing today. So a reminder of what this is about. We were working on our Seagull game, which we are going to get back to working on, but we wanted to have moving platforms in it, and we've tried doing moving platforms in a few ways in Arcade. It's always kind of come out kind of weird, and so we decided to do something that would be a little bit less, what's the word I'm looking for, prescriptive. Basically just the ability to have multiple tile maps in your game that are layered on top of each other.
Mm-hmm.
So the idea being, here, let me switch to sharing my screen, that you could have like the main tile map, which is this brick wall around us in the background. And then you could have these smaller tile maps, which could be platforms that are layered on top. Right. So this would be a platform, and then this pink thing down here would be a platform. And so to make this happen, we already have like the APIs for like creating these layers of tile maps. We want to make it so that these actually work in a physics engine, because as you can tell right now, we do have walls set in these tile maps, and they are not doing anything because we are just, going right through it. So anyway, let's get to coding. So what we did last time was we took the physics engine and we extended it. That's what we have right here. And this is all just code that is straight from the stock physics engine. But we deleted all of the code that we don't need to override because we're extending this other one. Hey, Breakfast. Can you hear Breakfast yelling, Joey?
I heard one yelp. Yes.
Okay.
One.
There's probably going to be more.
Yeah. Cat? That's from chat.
Oh, Breakfast. All right. Sometimes he just goes crazy, All right. So we've created this physics engine, but we're not actually using it yet. So let's go ahead and override the physics engine. So we're going to go ahead and do game.currentScene.physics engine equals new arcade physics engine. Wait, not that. Tile map layers.physics engine. And there we go. Okay, so nothing has changed because we haven't actually changed any of our physics engine code, but now it's at least actually being called so that when we make changes, we'll be able to see it. All right. So we have a lot of places in this code where the tile map is referenced, right? And basically, we're going to be going to all of those places, and we're going to be altering them to take into account all of our layers at once. So let's actually just do a Control F for TM. Okay, let me put on case sensitivity. All right. So, okay, we have a lot of calls to is on wall. So that's a really easy one for us to override. There we go. Arduino says, oh yeah, go ahead.
Besides doing wall collisions, will there also be like overlap events and stuff?
Yeah,
that was in our docket of things. Do we have that list anywhere?
Yeah, it's in another project. I should maybe recreate it. Let me recreate it.
But
no, it's right here.
Oh, it's right there.
Yeah.
Okay.
You know what?
So,
yeah, so we have like checking if it's overlapping with the tile map, but we should clarify that overlap and collision events fire for all tile maps. And I'm going to kind of treat this one as we're going to do this one last. I just want to get the collisions working first, All right. So back to where we were. Okay, so we have that TM is on wall, which that one's a really easy one for us to do. So we're going to go ahead and do that one real quick. We have is obstacle and get obstacle. is obstacle get obstacle, is obstacle get tile, TM enabled, Yeah, and then we have a bunch of calls to scale. And yeah, okay, I think this won't actually be that. So let's go ahead and make a function called isOnWall. And this is going to take in a sprite, and this is going to take in our tilemap layers. So, you know what? Let's go into custom.ts, which is where our state lives. Right here. And we're going to make a we're going to make an array called active tilemaps. And we're going to just store all of our tilemaps in this. The reason that I'm doing this as a separate array is we actually want this to be fairly performant because we're going to be calling it a lot in the physics engine. So I don't want to recalculate it every time we call it. So I'm just going to store it as an array that we can just keep like accessing. And now over here, we're going to go ahead and say protected update active tilemaps. Oh my God, breakfast. He just ran into my door and the whole thing shook. And then he bounced off it and ran up the stairs.
Nice.
Yeah. All right. So we're going to say for const layer of this dot layers if layer this dot tilemap or active tilemaps dot push layer dot map. Wait. Yeah, there we go. Cool. And then we also want to say this dot active tilemaps equals array like that. Okay. So when we do a set layer right here, we're going to go ahead and call this dot update active tilemaps. Very good. And now go over to physics.ts. And down here, where we were doing our implementation, we're going to say const tilemaps equals state dot active tilemaps. And then we're going to do, oh, wait, it's underscore state. There we go. For const tm of tilemaps, we're going to do if tm dot is, oh, this is on wall thing. Oh, this is on the tilemap class. Let's copy the implementation of that. We're going to go over to game, go over to tilemap.ts. Control F for is on wall. Turn off case sensitivity. And here we go. I'm going to go ahead and copy this. Cool. And go back over here. We're just going to pull this chunk out, go over there. Everywhere that we have this, we are going to put in tm instead. So tm.scale. And then right here, we're going to do tm.isObstacle. I don't know why it's saying any. I guess it's so messed up from this. Okay. If is overlapping wall sprite tm return true, and then down here return false. There we go. Okay. Let's see. This should be is wall, and this should be sprite. Okay, there we go. Now we have is on wall. All right, so we're going to go ahead and just do a control F for tm.is on wall. And right here, we're going to replace this one. So we're going to go ahead and do is on wall sprite like that. Go. All right, now this one takes in a specific tile map. But it's actually just updating the clipping for all of them. So yeah, we can replace this one too. So. Here we go. All right, this one is within move sprite. Okay, yep. This one is also good to replace. This one is in can resolve clipping. Yeah, this one's also fine to replace. So we're going to go ahead and just do. I guess I could just delete this tm dot. What this can resolve clipping thing is doing is just like shifting them around and trying to figure out if they are still overlapping if we move them like 1 pixel in each direction. And the idea being that if you're clipping but just barely, we'll just bounce you out, you know?
Yeah. You basically just lose all your, tile map benefits if you are fully clipping into something.
Okay. Now this is overlapping wall thing is actually, we need to take in a XY offset, right? Because our layers have XY offsets. So let's edit this. We're going to do X number, Y number, and we're just going to basically subtract these. Oh, whoops. Oh, shoot. This is a... And then do fx.sub end over here, delete, comma, wait. Oh, whoops. There you go. Some fancy cursor work there. Okay. So, great. All right. So this is going to adjust our left, right, top, bottom so that we are like on top of the sprite. Because if the sprite is at 50-50 and the X is at 60-60, then we want to be checking the sprite at negative. Yeah, that makes sense. We're going to pass one more thing here, which is going to be allow out of bounds. Hi, Lane. Maybe? I don't actually know how to pronounce your username.
Oh, hey, Leon. I know I'm from elsewhere.
Oh, yeah. Okay. So if we have allow out of bounds, then we want to make it so that if we are completely out of the range of the tile map, like we're outside, then we want to count that as not a wall, as opposed to the normal thing, which is we count that as wall.
We're doing good.
Yeah,
we're
all right.
Coding some updates to the physics engine for an extension, so making it so you can have lots of maps for a little game programming engine.
Yeah, that's the idea. Okay, wait, I need to go back to tilemap.ts. Is wall. Okay, so this is just doing is obstacle, which is not what I want. Okay, cool. All right. So wait, this is weird. Does this, so this is the is wall inside of tilemap data, right? Which is not checking bounds, which is actually good in this case. That's the behavior I want.
Yeah,
but
I think it gets handled elsewhere, like in the upper checks.
Because it gets called here, and then it gets is obstacle is called here. Is obstacle. Oh, yep, there you go. Okay, yeah. So because we're calling is wall instead of is obstacle, we're actually all good. Cool. All right. So, we're going to go ahead and take this allow out of bounds and say, all right, if it's wall, return true, else if allow out of bounds and tm dot is outside map call row, return true. There you go. Great. All right. And now we have to change this active tilemaps thing because we need the offset as well. So let's actually, whoops, go back over to custom.ts. We're going to go to where we make that active tilemaps array, which is right here. And we're going to make this be tiles dot, or we're going to make this be a tilemap layer instead. And then over here, we're going to say if layer and layer dot map, because they might not have a map defined, then we're going to go ahead and push the layer. Man, every day I wish that we had support for that. I know our TypeScript is too old and it would be too difficult for us to add support for that, but I want it. All right. Back to physics. Okay. So we're looping over our tile maps here, and then we're going to be passing in tm.map fx8 of tm.x fx8 of tm.y, and then we need to, oh wait, sprite map x, y. Yeah, and then we need to pass an allow out of bounds. So for allow out of bounds, we just want to make it, if it's the bottom layer, then we want to treat that as like the one boxing in.
Yeah, that makes sense, because the bottom layer is like always going to be the outermost one, because otherwise you would just be on top of the inner.
Exactly. It would just like make it so you couldn't draw anything else. Mm-hmm. So I'm going to convert this into regular old for loop. So over here, do const tm equals tilemaps of I. And then for this, we're just going to say I does not equal 0. There we go. All right. I actually don't know what effect this is going to have on our game. So let's just go ahead and run the code and see what happens. Okay, no effects. No effects.
Perfect.
Whoa. Okay, wait.
Nothing works.
Yeah, there we go. All right. This is not surprising. All right, so this is all good. We want to now go to wherever else the tile map was referenced. So I think we're going to do tm dot that, and then just kind of go through all of these that are not in the code we just wrote. Okay, tile map collisions. This is the main thing we're going to have to override. And then we have this is obstacle check. We're still inside of tile map collisions here. Yep. I'm just going to collapse tile map collisions because we know we're going to have to rewrite this function. Okay, we don't care about this enabled thing. Let's actually get rid of it. Don't bother checking. right. All right, cool. Okay. I think this is all good. All right, so we're gonna time to work on tile map collisions. This is the meat and potatoes of the physics engine. This is the big chunk that we need to like change.
Mhm.
So Joey, do you want to give a thing on what this does?
I have to remember exactly for sure, but this one is what we run after each increment, each step in the movement to handle the collisions in that increment. So we handle the movement step by step because we don't want to make it. So like if you're firing two projectiles and they should overlap, we don't want that to get missed. Or if it like would step through a wall, it doesn't get missed. But this one just handles most of the logic of, are we like getting into a wall? And
Yeah.
that's it.
So yeah, like Joey said, when we do a move, we don't just like teleport to the next location. We go like tiny moves till we get to the end. And every tiny move, we have to be like, did we hit a wall? And that's what this is, tile map collisions. So if we did hit a wall, then we stop. But otherwise, keep going. So let's look at where tile map collisions is called. So it gets called inside of move sprite. We can worry about this one later. This is what gets called when you set the X and Y of the sprite. We're going to be doing the physics first. So this is the move function, and this is what is actually moving all of our sprites. So for each of our sprites, we are changing their X by whatever the step X, step Y is, and then we are checking collisions on whatever the current tile map is, right? So this tile map is assigned somewhere up here. Yeah. So what we want to do instead is we want to take our tile map collisions function, and we want to make this take in an X offset and a Y offset, right? And also change this to be tile map data. All right. And so the idea here is we are going to do all of the same calls that we were doing on a tile map, but we are going to adjust our sprite's position based off of this X, Y. All right. So we have these calls to is obstacle that we're going to have to do. We also have these calls to register obstacle. I'm not even going to worry about that right now. Okay. So we need equivalence of this is obstacle and get tile, and well, get tile should be easy actually. Overlap tiles is a tile style location. Okay, yeah. So we need like a location creation function. All right. So we need an is obstacle, we need a get obstacle, and we need a get tile. It looks like. So let's go ahead and implement those functions. So first off, we're going to do is obstacle. This is going to take in a sprite. This is, sorry, not a sprite. This is going to take in a
Tile map row call.
Yeah. A row, wait. Column, row, and then allow out of bounds, just like before.
Mm-hmm.
And then we're going to go ahead and say if, actually, it's just this. Let me go ahead and just rewrite this as an if statement, as an or. So return this or this. And now up here, we can just do if is obstacle TM call row allow out of bounds. And there we go. Cool.
Nice.
All right. That's great. Let's go ahead and do get obstacle. So I don't actually remember what the obstacle like class entails. Do you?
I mean, it's largely just the tile map. I mean, it's only really used for tile maps that I remember.
Is it sprites.obstacle? Static obstacle?
Yeah. Then we add that list to the of like collided tiles.
So this takes in an image, a top, a left, a layer, and a tile index. Oh, this is kind of complicated. Okay, so why is this complicated? So the image, that's fine. Top, left, both fine.
Oh.
Layer, fine. Tile index. This is where it gets tricky because we have multiple tile maps, and each of them have different tile sets. All right. So if we give a tile, what'd you say, Joey?
We can be cute with it by bit shifting because there's a maximum of 256 tiles per.
Oh, I see what you're saying. We could do that. I'm wondering though if we should just override this static obstacle class.
That also works.
Let's just find where this tile index is being used. It's actually an optional parameter here. So pop,
as far as
we can just ignore it.
Yeah, as far as I remember it, this is just for like sprite is hitting wall right, whatever, stuff like that. And the blocks.
Let's open up common packages. And we're going to go ahead and search for static obstacle. Well, that didn't work at all. Code. Ugh, all right. GitHub. Holding back the good stuff unless I log in. Okay, do I have it? I might have it cloned. 1 second. Let's do terminal. There you go. Gonna take this off screen for a sec. Make dir work. cd work. Git clone. I don't think there's actually anything to hide here. Git clone this junk.
Okay, well, I have the files if you want them real quick. Obstacle.ts and games. That's about it.
I don't have Git installed on this computer. Sorry. We recently updated the stream computer, and I haven't reinstalled everything yet. I can't believe I didn't install Git, though. All right, what was the file?
So live/game and it's obstacle.ts is the class itself.
All right.
The other references are just in tilemap.ts for color-coded tile maps. That's deprecated. Physics, which we see in tilemap.ts.
Okay, so is this just used to like? I'm guessing we don't actually use the tile index anywhere.
I mean that's the references to this one. Let me find it in Sprite, see if that's referenced anywhere.
Unsigned Arduino says, I prefer command to PowerShell, LOL. Yeah, I don't typically use PowerShell. I mean, typically I use Windows Subsystem for Linux, but I know I don't have that installed on this computer, so.
Obstacles. So we reset it here. We check if there is one in a direction. No.
That's what I thought it was all we use it for.
There is a tile hit from block, but it's marked as deprecated. That one uses it.
All right. Okay, so then we're just going to go ahead and pass in. Okay, so it takes in a top and a left, which is kind of interesting. We need to pass in our X and Y. And we're going to go ahead and do call shifted by tm.scale plus x. That'll give us our left. This will give us our top. Next one is layer. We're just going to pass that in as 0. And then we need to get the image. So we're going to do tm.get tile image, tm.get tile, and then we're going to pass it in column. Oh, okay, that should do it. All right. Okay, cool. So we have isObstacle, we have getObstacle. Let's go ahead and actually call these. So we're going to go ahead and do isObstacle first. Okay, so in isObstacle, we're passing in an x0 and a y0. Those are our column and row. We are going to change this to be isObstacle. We're going to pass in tm, and then we need something to pass in for allow out of bounds. So I'm just going to put in a variable that we will fill in later. We're going to go ahead and add this to our tilemap collisions. There we go. And then we're going to go ahead and do getObstacle and pass in our tm, x0, y0, and then our x and y. I think we actually are overloading xy here. So we're going to go ahead and rename this to x offset and y offset. Cool. All right, that takes care of those. Let's scroll down to the next one. Here we go. Change this to isObstacle, tm, allow out of bounds. So the other day, I had to take one of my cats to the vet. He's fine. He's just an idiot, and likes to eat plastic. But they had a thing in the front, which was Jolly Ranchers. And I was like, I have had a Jolly Rancher since I was a kid. And I had it, and I was like, this is a pretty good candy. This is good. So I was like, all right, I'm going to go out and buy a pack of Jolly Ranchers. So I did. Bought a pack of Jolly Ranchers. Didn't realize that that is an infinite amount of candy. All right. Because each Jolly Rancher, takes a while to eat. And so, yeah, it takes a long time. But perhaps the bigger problem is that when I got the pack, it was like, I would say like 4/5 of it was grape. I don't know what went wrong in the factory, but they only gave me grape Jolly Ranchers. And then there were like a few other ones mixed in. And I think grape is objectively the worst flavor.
Yeah. It's not like the cherry or the blue one, so I don't know.
Watermelon's the best flavor.
Watermelon's pretty good.
On Sign Arduino, it says best flavor is blue. And says ask for a refund, LMAO. Yeah, I don't know if the Safeway employee that I purchased it from would know what to do with that situation. But I guess I could mail into the Jolly Ranchers Corporation, which is probably Hershey's or something.
Mm-hmm.
All right. Okay. Register obstacle. We need to figure out something to do for that. We'll worry about that later. Let's finish up these first. So we're going to go ahead and make this isObstacle. Pass in tm, x0, y0, allow out of bounds. And then we're going to do tm get tile. Oh, okay. So this is another thing we have to implement. So, or actually, no, we're good. This is a location. No, okay, no. So this is something we have to implement. Yeah. So we're going to do get tile location. And this is going to take in a tile map, x0, y0. It's also going to take in x offset, y offset. And yeah, that should be good. All right. Let's implement this function. we're you know, the number of errors we have is going down, which is good place to be.
Someday it'll get to 0.
Maybe we'll get to run this code before the stream is over today.
That'd be pretty good.
Okay. All right. So get tile location. All right. So we need to create a tile location thing. And this one is actually kind of complicated because if we go ahead and look at where the tile location is defined, this is inside of tiles.ts or just tilemap.ts. Yeah. So the location takes in a map, which it doesn't even store. Okay, never mind. It's not complicated.
Nice. Yeah, we have that return get tile map that returns the current tile map.
So we're gonna go ahead and override this location, extend this location, and then make tile map return like the actual tile map. And then we also need to do these XYs so that we like adjust them correctly and stuff.
Yeah.
Yeah, this should be easy enough. And then we have this thing that says legacy do not use. Oh, this is used by our legacy tilemaps extension.
Yeah, that's the color-coded tile map compat.
Yeah, all right, I'm just gonna copy this whole class and we're going to override it. So let's go ahead and make a new file. We're gonna call this location.ts. And on over here, namespace, tile map layers. There we go. Paste this guy in here. We can get rid of all of these comment annotations, and actually we can just get rid of these entirely. But we need to keep the X, the Y, left, top, right, and bottom. Actually, do we need X? Yeah, we do. Okay. X, Y, left, top, right, bottom, tile sets. Nope, this one's fine. Go ahead and get rid of that. And get rid of the deprecated one. We don't care. Oh, and let's go ahead and make this extends tiles.location. And we're going to go ahead and call super call row. Okay, but we're actually going to store this map, unlike the other one. So we're going to go ahead and do protected map tiles.tilemap. And we're going to go ahead and say this dot map equals map. And then in here, we're going to go ahead and return. Oh, this gets a tile map, not a tile map data. Okay, that should be data. All right, I'm gonna toss this. Don't need that. Okay, this is wall right here. We're gonna go ahead and do is, we'll call our function that we made. So let's head back over to physics.ts. Go over here. We're going to go ahead and export these functions we made. All right, and we need access to the tile map for these guys. Now, I think we do actually create tile maps for these, right? Like, let's go back over to custom.ts. Yeah, so we have this drawer right here, which has a tile map. So I think maybe instead of passing around the tile map data like we've been doing, we should maybe just pass around this tile map layer instead so that we can have access to this tile map.
That makes sense.
Well, it does and doesn't. Yeah, all right. We're going to have to change our tile map class to do the is obstacle stuff properly. We'll worry about that later. Okay, so let's change this to be map is going to be tilemap layer. Tilemap layer. Okay, I need to export this, I think. Yep.
Export it, yeah.
All right. That's all good. We're going to go to our getters and right here, and we're going to make these take into account our x and y. So for all of these, we're just going to be doing this dot map dot x plus like that. And then for the y ones, you guessed it. Okay, we don't actually have to mess with this. This is actually fine. And then we have this get image, which this is also fine. So just toss that. Can get rid of this. This is also fine. Get rid of that. And this is also fine. So get rid of that. Cool. Okay.
Nice.
Good enough. We have the basic things that we need to override here. Go back over to physics.ts. We're going to go down to our get tile location. And instead of taking in a tile map data and an XY, we're just going to pass in a tile map layer. And we're going to do return new location of column row TM, like that. Now we're going to head on over to where we do get tile. Oh, I guess we already changed it here. So we're going to do get tile location. We're going to get rid of this X offset, Y offset business. And we're going to change our tile map collisions function.
Oh boy.
What's that?
Just every time I see it, I forget how big this function is.
Yep. Like that. And then we can delete this X offset, Y offset. This is going to make everything angry. And it's also going to make it so that we're no longer extending this correctly. So we'll have to figure that out. But for now, this is fine. All right. Okay. So for these, we're going to go ahead and make this be tm.map and then tm. Oh, then x0, y0. That's all fine. tm.map. And then this is going to be tm.x, tm.y. I'm sorry, Arduino says make everything angry, LOL. Very common sight when I'm coding. Yeah. Mm-hmm. That's just, coding. Okay, so this is going to be tm.map, tm.map, tm.x, tm.y. Okay. go, okay, need to mess with that one. So do tm.map.scale. Register obstacle. Do tm.draw. Just delete this. It's an optional parameter. Yep, optional parameter. Get rid of that. Okay. Is obstacle, great. This needs to be tm.data. Sorry, .map. Okay. And all right. Now we're good. Okay, so we're going to go ahead and take our tilemap collisions function. And we're going to rename this to the creatively named tilemap collisions 2 electric boogaloo. Okay, cool. So this is just because we need to have a version of this function, but we need to, we can't override the existing one because we're passing in different arguments.
Mhm.
So, all right, cool. So now we're down to 2 errors because we just need to actually call this appropriately in these places. So we're going to go ahead and do for let's I equals 0. I is less than, let's see, we're going to go ahead and do let's layers equal state dot active tile maps. Dot length I plus plus right here. MS, this has to be layers of I. And then we need allow out of bounds is I equals 0. Here we go. I'm going to copy this. Go down to move sprites. Do the same thing. Except we're going to do const layers equals state dot active tile maps. And we don't care about this enabled business actually. So we can actually delete that back up there. But okay.
Oh. 2 errors in location.ts now. Oh, because they're defined in the base class.
Did it actually recompile is the question. All right. Well, still not working, but yeah.
No errors, but
no errors though. So that's a bonus. Let's save. All right, we have 10 minutes. 10 minutes to get this working. Okay, so one thing is we need to go ahead and get rid of this enabled check. I think that's actually the entire thing that's wrong here. And then go over to where we define this tile map. Just go ahead and delete that. We don't need it. And then this guy is upset because we're going to just change this to be layers.length. Nope, still not working, but that was definitely a bug at least. All right, do we have anywhere else for checking for enabled? Nope. All right, well.
Could one of the functions that call this speed check? No, makes sense.
All right, time to put in some console logs. Let's start right here. Console.log layers.length. There you go. 33333. That's correct. That's exactly what we want. So we have just confirmed at least that our code is getting called and that we do actually have the layers stored. So that's all good. Let's do, okay. So inside of our tilemap collisions too, let's read through this code. So we have a x diff, y diff. We then check our collisions. Right here, for each of these, we're doing is obstacle on this map.
So at the very least, I would think that the outer one is working. Should be working still because we didn't like the bottom layer, right? Like I could see the other ones with the offset being different, but that one should still work just normally.
Yeah, okay. The problem here is we have these x0 and y0, right?
Mhm.
Is the outer one working? Yes, the outer one is working.
Oh, okay. So that makes
sense. We are actually colliding with this one. It's just up here.
Yeah.
And that's because we are not taking the x offset and y offset into account. All right. We are for this get obstacle, but we're not for this is obstacle call. We actually can't do it for this is obstacle call because we need to adjust our column and row based off of it, right? So we have this y0 right here. This y0 right here is figuring out like a location, and then it's shifting it by the tile scale. So what we need to do here is we need to take this location that it's figuring out, and we need to subtract our y, basically. So we're going to go ahead and do fx.sub. Shift this over.
Are we going to, I guess we'll be double counting it and get obstacle for a moment then? If get obstacle is already handling it with the offsets.
I don't think, no, we're actually good because this is just converting it into a left top. So gotcha. This is already assuming that this is also shifted. So yeah. All right. And then right here, this is going to be fx8 of tm.y. Like that. All right. So that's the first one. Let's do this one over here now. So this is x0. We're going to go ahead and do, once again, fx.sub. That's cool. All right. There should be two more of these right here. So we're going to go ahead and do fx.sub. By the way, while I'm doing this, Joey, do you want to explain what all this fx business is?
Yeah, I was just thinking if we should. So fx is in our game engine the fixed point representation. So normally our nets follow, closer to JavaScript semantics, so you can have big numbers and lots of decimal places. That can be slow, especially on hardware. When you're running these on little guys like this, right? They don't have a very strong processor. They don't have a separate. I mean, sometimes they do have a separate core, but we don't actually use it for running computations with fixed point values that are very large. So fx is just representation of numbers with a fx8, so 8 decimal. Well, 8-bit. I forget the exact value.
Yeah, it's take an integer, shift it over 8 bits, and then we use those 8 bits for the decimal point.
Yeah. And so that way we can still have like 4.5, right? But we get the benefits of treating it like math, like integer math, which is very fast on, these devices. They made, I think, I want to say it was as much as like 2 times performance increase.
Yeah, it's a lot.
It's very significant. It makes it really annoying writing this math just because instead of a plus, you have to write fx.add and treat it as parameters. But that all gets elided out when we're actually compiled to.
Oh, we're so close. Let's see, fx8 of tm.y.
I'll
Two
also
more.
say this is not something you probably ever want to
Sure.
use in your own code. Is FX? It's only for like the core.
Whoa.
Something happened there. The core game engine that this is running, thousands of times a second per frame, which is 20, 30 times a second. This is,
Yeah. Don't over optimize. All right. We you can trust that usually this is not an issue.
Yeah.
It's just the physics engine runs for so many sprites, so many steps every frame that it makes sense for us to do this optimization. If you are writing like a 3D renderer, then yeah, consider doing fixed point math. If you're doing anything else, don't worry about it.
Yeah.
Okay, cool. So we now have the collision detection working correctly. All right. So when we hit this, we are actually triggering something. Obviously, it's the wrong behavior, but
it's a behavior, which is all we ever wanted.
Yeah. So this is at least
the clipping resolution is off, and that makes sense.
Yes.
Because it's it's treating you as if you're clipping. It's like, oh well, I can put you off the screen and everything's good.
Yes, something like that. Okay, so this is probably where we're gonna have to stop for today, but we made some good progress. And I think we got the hardest part done, or at least the part that has the most code changes. And now it's just going to be kind of figuring out the little bits that are left. And then we get to the easier stuff, which is like defining the actual APIs, like are we colliding with this tile map and stuff like that. So with that, thanks for tuning in, everybody. Announcement. I haven't put it up on the forum yet, but we are going to have a new mini game jam. So our last mini game jam was construction themed. So the mini game jam theme for this month is going to be the opposite, destruction. So make a game where you blow stuff up. I don't know. Have fun with it. I'm going to put it up there, and this is going to be a perfect chance for me to talk about the obscure video game that Steven Spielberg made, which is Boom Blocks. Yeah, about this joint. All right, I'll pull it up while we do outros. Okay. Anyway, I am Richard at Richard on the MakeCode forum.
I'm Joey at J1 on the MakeCode forum. The other thing to note is that we won't be here on Wednesday because we'll be at a little conference thing. So it's not
yes, no stream on Wednesday, right? Yeah, Boom Blocks was a physics game for the Wii, and it was made by Steven Spielberg.
I did see this. I didn't know it was by Steven Spielberg.
Yeah, I owned this. And you're like, oh, Steven Spielberg, I bet it's like a cinematic game with like a big story and stuff like that. No, it's a thing that has a bunch of Jenga blocks and you throw stuff at them and then they fall down. So
what else do you want from a video game? Really?
Yeah. All right. Thanks for tuning in, everybody. We'll see you later. Bye.
See you. Bye.